Find dy by dx at theta is equal to pi by 4 if x is equal to a e power theta times of sine theta minus cos theta and y is equal to a e power theta of sine theta plus cos theta. Let's differentiate with respect to theta. So we have dx by d theta is equal to a into e power theta of, by using UV rule, differentiation of sine theta minus cos theta is cos theta minus cos theta differentiation is plus sine theta, again plus sine theta minus cos theta into a differentiation of e power theta is e power theta. So we can write here a e power theta taken common, cos theta plus sine theta plus sine theta minus cos theta. So here cos theta gets cancelled. So we can write 2 times sine theta, that is 2a e power theta into sine theta, that is for dx by d theta. Now consider y is equal to a e power theta into sine theta plus cos theta. Let's differentiate with respect to theta. So we have dy by d theta is equal to a e power theta into sine theta differentiation is cos theta and cos theta differentiation is minus sine theta, and again plus a into sine theta plus cos theta times differentiation of e power theta is e power theta. So we can take a e power theta common, write cos theta minus sine theta plus sine theta plus cos theta, which is equal to sine theta get cancelled, 2 cos theta, that is 2a e power theta into cos theta. And now we need to find dy by dx. So dy by dx we can write dy by d theta upon dx by d theta, which is equal to 2a e power theta into cos theta divided by 2a e power theta into sine theta. From 1 and 2 we can say this is 1, say this is 2, from 1 and 2. So we may cancel here 2a e power theta numerator and denominator, which is equal to cot theta. And now we need to find dy by dx at theta is equal to pi by 4, which is equal to cot pi by 4, which is 1. So we can go with an answer 1. Evaluate integral minus pi by 2 to plus pi by 2 cos x upon 1 plus e power x dx. So let us consider to be this is I. Now by using the property integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. So we can write I is equal to minus pi by 2 to plus pi by 2 cos of a plus b minus x, that is minus pi by 2 plus pi by 2 minus x upon 1 plus e to the power minus pi by 2 plus pi by 2 minus x dx, which is equal to minus pi by 2 to plus pi by 2 cos of negative x divided by 1 plus e to the power negative x dx. Upon simplifying, you can write minus pi by 2 to plus pi by 2. Cos of negative x is cos x divided by 1 plus 1 by e power x, that is 1 plus e power x divided by e power x will come in the numerator. Say this is 1, and say this is 2, adding 1 and 2, adding 1 and 2, we'll get I is equal to, or I plus I, integral minus pi by 2 to plus pi by 2, cos x upon 1 plus e power x, and here same integrals we have limits, so we can directly e power x into cos x upon 1 plus e power x of dx, which is 2I is equal to minus pi by 2 to plus pi by 2 cos x upon 1 plus e power x into 1 plus e power x dx, so which is integral cos x, and we have 2I is equal to integration of cos x is sin x over the limits minus pi by 2 to plus pi by 2, that is sin pi by 2 minus sin of minus pi by 2. Sin pi by 2 value is 1 minus sin of minus pi by 2 is minus 1. So we can write 2. So that we can write I is equal to, or 2I is equal to 2. So I is equal to 1. So integration minus pi by 2 to plus pi by 2 cos x upon 1 plus e power x dx value is 1. Evaluate integral 0 to pi x sin x upon 1 plus cos square x dx. So let us use the property integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So here we can write I is equal to 0 to pi minus x of sin of pi minus x divided by 1 plus cos pi minus x square dx. So we can also write it as 0 to pi minus x into sin of sin pi minus theta is sin theta, and cos pi minus theta is equal to minus cos theta, but cos square of pi minus theta will be cos square theta. So we can write into sin x divided by 1 plus cos square x dx. So that is integral 0 to pi sin x upon 1 plus cos square x dx minus integral 0 to x sin x upon 1 plus cos square x dx. And here we can say that this is 0 to pi x sin x upon 1 plus cos square is same I. So we can write it as I is equal to integral 0 to pi sin x upon 1 plus cos square x dx minus I. That is 2I is equal to, and here let us substitute, put cos x is equal to t, so that minus sin x dx is equal to dt. So here we can write minus pi sin x dx is dt divided by 1 plus t square, and coming to the limits, when x is equal to 0, cos 0 is equal to 1, so t is equal to 1, and when x is equal to cos pi is equal to minus 1, so we can write here minus 1. So 2I is equal to minus pi times of 1 to minus 1. 1 upon t square is nothing but tan inverse of, so we can write minus pi tan inverse of t over the limits plus 1 to minus 1. So we can write 2I is equal to minus pi of tan inverse of -1 minus tan inverse of +1, that is I is equal to minus pi by 2 times tan inverse of -1 is minus pi by 4 and tan inverse of 1 is pi by 4, that is minus pi by 2 into minus 2 pi by 4, or we can write pi square divided by 4. So the answer can be taken as pi square divided by 4. Evaluate integral root of 1 minus root x upon root of 1 plus root x dx. So whenever we have the integral of the form 1 minus root x or 1 plus root x, we can substitute x is equal to cos square 2 theta or cos square theta. So let us substitute x is equal to cos square theta, cos square 2 theta, so that we can write 1 plus root x is equal to, or 1 minus root x is equal to 1 minus root of cos square 2 theta, which is equal to 1 minus cos 2 theta. 1 minus cos 2 theta is 2 sin square theta, and 1 plus root x is equal to 1 plus root of cos square 2 theta is equal to 1 plus cos 2 theta is equal to 2 cos square theta. And also we can remember, when x is equal to cos square 2 theta, then sin square 2 theta is equal to 1 minus cos square 2 theta, that is 1 minus x. So sin square 2 theta is equal to 1 minus x, we can remember. And now our integral root of 1 minus root x is nothing but root of cos square 2 theta. So we can write it as 2 sin square theta upon root of 2 into 1 plus root x is 2 cos square theta into dx is nothing but whenever x is equal to cos square 2 theta. So differentiating, we'll get dx is equal to 2 cos 2 theta into differentiation of cos is minus sin 2 theta into differentiation of 2 theta is 2. So we can write minus 4 sin 2 theta into cos 2 theta d theta. So integral root 2 into sin theta upon root 2 into cos theta into minus 4 sin 2 theta, we can write 2 into sin theta into cos theta into cos 2 theta d theta. So we can cancel here cos theta, sin square theta we can write. So minus 8 we can write, minus 8 times of sin square theta into cos 2 theta d theta. That is minus 8 times sin square theta is equal to, from here 1 minus cos 2 theta is equal to 2 sin square theta. So we can write sin square theta is equal to 1 minus cos 2 theta, 1 minus cos 2 theta upon 2 into cos 2 theta. So that is minus 4 times integral cos 2 theta minus cos square 2 theta d theta, which is equal to minus 4 times integration of cos 2 theta is minus sin 2 theta upon 2 minus integral cos square 2 theta, we can write it as, since cos square theta is equal to, or cos square 2 theta is equal to 1 plus cos 4 theta divided by 4, we can write 1 plus cos 4 theta divided by 2 d theta. Let us simplify this. So we can write here First one minus of minus plus 2 times of sine 2 theta minus, and minus of minus plus here again integration 2 times 1 times d theta is theta, and again plus integration of cos 4 theta is minus sine 4 theta divided by 4 plus integral constant c, that is 2 times sine 2 theta plus 2 theta minus 1 upon 2 sine 4 theta plus c. And we know that sine square 2 theta is equal to 1 minus x, so we can write 2 times of root of 1 minus x plus 2 into, and theta is equal to, when x is equal to cos square 2 theta, or cos 2 theta is equal to root x, or 2 theta is equal to cos inverse of root x, or theta is equal to cos inverse root x upon 2. So we can write 2 theta is equal to, or here we can write 2 theta is equal to cos inverse root x minus 1 by 2 sine 4 theta, that is 2 sine 2 theta into cos 2 theta. So we can write 2 times root of 1 minus x plus cos inverse of root x minus sine 2 theta is equal to root of 1 minus x, and cos 2 theta is root x. So 2 root of 1 minus x plus cos inverse root x minus root of sine in root of 1 minus x into root x plus c is the answer. Find the general solution of the homogeneous differential equation. So it is given, it's a homogeneous differential equation. So we can write dy by dx is equal to x plus 2y upon x minus y. The method of solving homogeneous differential equations is by taking y is equal to vx, and differentiating we have dy by dx is equal to v plus x into dv by dx. So let us write dy by dx is equal to v plus x into dv by dx is equal to x plus 2 times of vx upon x minus vx, that is v plus x into dv by dx is equal to x taken common here 1 plus 2v upon x taken common in the denominator 1 minus v. So we can write x into dv by dx is equal to 1 plus 2v upon 1 minus v minus v, that is x into dv by dx is equal to 1 plus 2v minus v plus v square upon 1 minus v. Or here we can write x into dy by dx is equal to v square plus v plus 1 upon 1 minus v, or we can write 1 minus v upon v square plus v plus 1 into dv is equal to dx upon x. Now integrating on both the sides, so we'll get integral 1 minus v upon v square plus v plus 1 into dv is equal to integration of dx upon x. So let us find the integral, the left side separately. We have integration 1 minus v upon v square plus v plus 1 dv, which is in the form of integration of px plus q upon ax square plus bx plus c dx. So where we can solve by using the method px plus q is equal to a into d by dx of the denominator, that is ax square plus bx plus c plus constant b. So here we can write 1 minus v is equal to a into d by dx of the denominator, that is v square plus v plus 1. Let us use differentiate with respect to v, plus again some constant b. So we can write 1 minus v is equal to a times of 2v plus 1 plus b. Comparing the coefficients of y, we can write minus 1 is equal to 2a, and comparing the constants here, 1 is equal to a plus b. So here a is equal to minus 1 by 2. If I substitute here, 1 is equal to minus 1 by 2 plus b, or b is equal to 1 plus 1 by 2, that is 3 by 2. So the value of a is minus half and the value of b is 3 by 2. And now 1 minus v upon v square plus v plus 1 integral dv is equal to, we can write a value is minus 1 by 2. So minus 1 by 2 integral 2v plus 1 upon v square plus v plus 1 dv, and constant b is equal to 3 by 2. So plus 3 by 2 times integral 1 upon v square plus v plus 1 dv. So that minus 1 by 2 in the first integral, since we know that the differentiation of the denominator is the numerator, so we can substitute or put v square plus v plus 1 is equal to t. So which implies differentiating will get 2v plus 1 of dv is equal to dt. So in the first integral, we can write it as minus 1 by 2 integral of 2v plus 1 of dv is dt divided by t. And coming to the second integral, in the second integral, we have the denominator v square plus v plus 1. We can write it as v square plus 2 into v into 1 by 2 plus 1 by 2 whole square, and again minus 1 by 2 whole square plus 1. Or we can write v plus 1 by 2 whole square, and here 1 minus 1 by 4 is 3 by 4. That is v plus 1 by 2 whole square plus root 3 by 2 whole square we can write. So we can just consider plus 3 upon 2 integral 1 by v plus 1 by 2 whole square plus root 3 by 2 whole square dv. And again in this integral, let us substitute v plus 1 by 2 is equal to some p, so that dv is equal to dp. So our integral can also be written as 3 by 2 times integral 1 by p square plus root 3 by 2 whole square dv is equal to dp. And the first integral we have minus 1 by 2, 1 upon t dt is log mod t. So which is equal to minus 1 by 2 log mod t. T value is nothing but here v square plus v plus 1 plus 3 by 2 times of, it is in the form of integral 1 upon x square plus a square, which is 1 upon a tan inverse of x by a, that is p divided by root 3 by 2 plus some constant c. So finally we can write minus 1 by 2 log mod of v square plus v plus 1 plus 3 by 2 into 2 by root 3 tan inverse of 2p divided by root 3 plus c, or minus 1 by 2 log mod of, your v is nothing but, or let us write at a time, v square plus v plus 1 plus 3 by root 3 tan inverse of 2 into, here p is nothing but v plus 1 by 2, so 2 times of v plus 1 by 2 divided by root 3 plus c. Now let's replace y is equal to vx, or v is equal to y by x. So we can write minus 1 by 2 log mod of y square by x square plus y upon x plus 1 plus 3 upon root 3, we can write it as root 3 times tan inverse of 2 times of a 2v, v is nothing but y by x plus 1 divided by root 3 plus c, or we can write 1 by 2 times log y square plus xy plus x square upon x square plus root 3 times tan inverse of 2y plus x upon x root 3 plus c. And we have the other side. This is only integral of, this is just integral of 1 minus v upon v square plus 1, v square plus v plus 1 dv. And the other side we have dx upon x. Let us write here, which implies is equal to integration of 1 upon x is log mod x plus some constant. Here say here c1 and this is c2. So we can write here log y square plus xy plus x square minus log x square 1 by 2 times it is there. So we can write plus root 3 times tan inverse of x plus 2y or 2y plus x upon x root 3 plus some constant c1 is equal to log mod x plus c2, or we can write 1 by 2 log x square plus xy plus y square minus 1 by 2 log x square plus root 3 times tan inverse of 2y plus x upon x root 3 minus, we can write minus log mod x is equal to some constant, or 1 by 2 log x square is nothing but log x we can write, and here we can write it as log under root of x square plus xy plus y square, and this is log under root of x square is log mod x we can write plus root 3 times tan inverse of x plus 2y upon x root 3 minus log mod x is equal to constant, and here we can cancel these two terms, and so finally the answer is log root of x square plus xy plus y square plus root 3 tan inverse of x plus 2y upon x root 3 plus c is equal to 0. Solve the linear programming problem graphically. Minimize z is equal to 300x plus 400y subject to constraints 6x plus 10y is greater than or equals to 60, and 4x plus 4y is greater than or equals to 32, and x is greater than or equals to 0, y is greater than or equals to 0. Let us draw the graph. Since it is given x is greater than or equals to 0, y greater than or equals to 0, so our solution must be in the first quadrant. So let us draw the graph in the first quadrant. The first line, let us consider the equation of the first inequality. 6x plus 10y is equal to 16. So dividing with 60 will get x upon 10 plus y upon 6 is equal to 1. So x intercept is 10 and y intercept is 6. So we can draw the line. So this is 6x plus 10y is equal to 60, and the inequality greater than or equals to 16. By substituting origin 6 into 0 plus 10 into 0, 0 is less than 60, but here it is given greater than or equals to 60. So origin is not the solution. So we can say that the shaded region will be away from the origin. So we can consider it is the other side, other half plane where origin is not containing. And let us consider the second equation. So we have 4x plus 4y is equal to 32. So dividing with 32, so we can write x upon 8 plus y upon 8 is equal to 1. So the intercepts are x intercept is 8, so 8 comma 0, and the y intercept is again 0 comma 8, and therefore the line can be drawn passing through these 2 points. So this line equation is 4x plus 4y is equal to 32. And coming to the region, we can shaded the region. The shaded region will be substituting origin 4 into 0 plus 4 into 0, that is 0 is less than 32, but the inequality is given here greater than or equals to 32. So the solution part will not be containing origin. So we can say that the shaded region will be away from the origin. So you can say so that we can just conclude the close the feasible region will be unbounded, and the corner points are, say this is a 10 comma 0 corner points, a 10 comma 0, and b we need to find by solving the two equations. Let us solve the equations. 4x plus 4y is equal to 32, and 6x plus 10y is equal to 60. Solving these two equations, we can write 2x plus 2y is equal to, or we can also write it as x plus y is equal to 8, and here we can write x plus 10 upon 6, that is 5 by 3, y is equal to 10. By subtracting this both, 1 minus 5 by 3, that is minus 2 by 3, y is equal to 8. 8 minus 10 is minus 2, that is y is equal to 3. When y is equal to 3, so x is equal to, since x plus y is equal to 8, so x is equal to 5. So here we can consider the point as 5 comma 3. So another point, let us say b is the point 5 comma 3, and say c point is 0 comma 8. Let us check the profit function at these three corner points. Z is equal to 300x plus 400y. So at the point 10 comma 0, we can write Z is equal to 300 into 10, 3000, plus 400 is into 0 is 0. So 3000, and another point 5 comma 3, we can write Z is equal to 300 into 5, that is 1500, plus 400 into 3, that is 1200, which is equal to 2700. And at the point C 0 comma 8, so Z is equal to 300 into 0 is 0, 400 into 8 is 3200. So the sum is 3200. Since the question is about the minimize, so the minimum is getting 2700 at point 5 comma 3. So we can conclude that minimize of the function is 2700 at the point 5 comma 3. A bag 1 contains 5 red and 4 white balls, and bag 2 contains 3 red and 3 white balls. So here bag 1 containing 5 red and 4 white balls, and bag 2 containing 3 red and 3 white balls. So total here 9 balls, and here it is 6 balls. And now 2 balls are transferred from the bag 1 to bag 2. 2 balls are transferred from bag 1 to bag 2, and then 1 ball is drawn from the bag 2. So when 2 balls are transferred, then bag 2 containing the 3 possibilities we have. If suppose the 2 balls are red, 2 red balls are transferred from bag 1 to bag 2, then we'll have, so total 3 red balls plus 2 red balls, that is total 5 red balls, and again 3 white balls. And if suppose both are white balls, 2 white balls being transferred, then in that case we have 3 red plus 5 white balls. And in the case of 1 red and 1 white ball transferred, so we have the probability, we have, so total 4 red plus 4 white balls. And also we can assess that when 2 balls are transferred from bag 1 to bag 2, the probability of selecting 2 red balls is, out of 5, 2 are selected, 5C2 divided by total number of balls is 9, so 9C2. So 5C2 upon 9C2 value is 5 factorial 5C2 upon 9C2 is equal to 5 factorial by 3 factorial into 2 factorial into 2 factorial into 7 factorial divided by 9 factorial. So we can write here 5 into 4 into 3 factorial divided by 3 factorial into 7 factorial divided by 9 into 8 into 7 factorial. So we can cancel here 7 factorial, 7 factorial, and here 3 factorial, 3 factorial get cancelled, and here 4 ones are 4 2 times get cancelled, so 5 by 18. So here we can say 5C2 by 9C2 is 5 by 18. And now when 2 balls are transferred, 2 white balls are transferred is, so we have the probability 4C2, we can write 4C2 divided by 9C2. So from 4 balls, 2 white balls are selected. So out of total 9C2, 9 balls, 2 are selected. So 4C2 by 9C2 is 4C2 upon 9C2 is equal to 4 factorial by 2 factorial into 2 factorial into 2 factorial into 9 factorial divided by, sorry, 7 factorial by 9 factorial, that is 4 into 3 into 2 factorial by 2 factorial into 2 into 2 factorial into 7 factorial divided by 9 into 8 into 7 factorial. So we can cancel here 2 factorial and here 2 factorial, and again 7 factorial we can cancel, and here 4 ones are 4 2 times. So we have 3 by 18. So here the probability is 3 by 18 when 2 white balls are transferred. And coming to the when one red ball and 1 white ball transferred, so we have the probability 5C1, out of 5 red balls 1 is transferred, so 5C1 into, and the next one is out of 4 white balls 1 is transferred, so 4C1 into 5C1 into 4C1 by 9C2. So 5C1 value is 5, into 4C1 value is 4, and 9C2 value we can write it as 9 factorial by 2 factorial into 7 factorial. So that is 9 into 8 into 7 factorial. So 4 2s are 8, so which is 5 by 9. So the probabilities of transferring 2 red balls is 5 by 18. Probability of transferring 2 white balls is 3 by 18. And probability of transferring 1 red ball and 1 white ball is 5 by 9. And now there are in bag 2, there are 5 red balls and 3 white balls. So the probability of selecting the red ball means again one ball is drawn from the bag 2 and that bag is red. So selection of the red is 5 out of 8, and here 3 out of 3 red balls are there, so 3 out of 8, and here 4 red balls are there, 4 out of 8. So by Bayes theorem we can say now, since we required if the ball drawn from the bag 2 is red, and means it is given that it is red, and we need to find the probability that one red and one white ball is transferred from the bag 1 to bag 2. So one red ball and one white ball, we need to find this probability, so which is equal to, so we can write this is 4 upon 8 and here it is 5 upon 9. So 4 by 9 into, sorry, 4 by 8 into 5 by 9 divided by the remaining total probability is 5 by 18 into 5 by 8. So we can write 5 by 18 into 5 by 8 plus 3 by 18 into 3 by 8 plus again 4 by 8 into, so 5 by 9 we can write it as 10 by 18. So that the numerator 18 into 8 and the denominator we can simplify here, 4 into 5, let us multiply here and divide with 2. So 18 upon 18 times 8 in the denominator and numerator gets cancelled, so 5 2s are 10, 10 4s are 40, divided by here it is 25 and here it is 9 and here it is 4 tens are 40. So 40 upon 25 plus 9 34, 34 plus 40 is 70, 74. So 40 upon 74, or we can write 20 upon 37. So 20 by 37 is the probability. When expressing in mathematical form, so let us say E1 is the event when two balls are transferred which are red, and E2 is the event the two white balls been transferred, and E3 is the event where one red ball and one white ball been transferred, and A is the event ball drawn is red from the bag 2. So we have P of E1 is equal to 5 by 18, that is 5C2 divided by 9C2, and P of E2 is equal to 3 by 18, and P of E3 is equal to 5 by 9. And also now P of A by E1 means probability of the ball drawn is red when two red balls are transferred is 5 by 8, and probability of a ball drawn is red when it is two white balls been transferred is 3 by 8, and probability of ball drawn is red given that one red and one white ball been transferred, which is equal to 4 by 8. So by total probability theorem, and the required thing is probability that one red and one white ball is transferred, and given that it is ball drawn from the bag 2 is red, so which is equal to P of E3 into P of A by E3 divided by P of E1 into P of A by E1 plus P of E2 into P of A by E2 plus P of E3 into P of A by E3, which is equal to P of E3 is nothing but 5 upon 9 into P of A by E3 is 4 by 8 divided by P of E1 is 5 by 18 into 5 by 8 plus P of E2 is 3 by 8 in 18 into 3 by 8 plus 5 by 9 into 4 by 8. For the simplification purpose, we can just multiply and divide with 2 here. So in the denominator is 18 into 8, and in the numerator also let us multiply and divide with 2, so that 9 2s are 18 into 8 in the denominator, and the numerator and denominator both gets cancelled. So we can write 5 into 4 into 2 divided by 5 5s are 25 plus 9 plus 2 5s are 10 4s are 40, which is equal to 5 4s are 22s are 40 divided by 25 plus 9 34 plus 4 74, or we can write 20 divided by 37. So 20 upon 37 is the answer. Find the probability distribution of the random variable x, which denotes the number of sixes in two tosses of a die. So the possible values can be taken as 0 number of sixes, or 1 number of sixes, or both 2 number of sixes. And let us consider A getting 6, and let us consider A bar not getting 6. So that probability at x is equal to 0, which is probability it's not getting 6 in any of the dice, that is P of A bar into P of A bar. Probability of getting 6 is 1 out of 6, and probability of not getting 6 is 5 out of 6. So we can write 5 out of 6 into 5 out of 6, that is 25 divided by 36, and probability of getting x is equal to 1 means in any one of the dice is 6, that is probability of A into probability of getting A bar, or probability of not getting into probability of getting. So probability of getting 6 is 1 by 6 into probability of not getting 6 is 5 by 6, or probability of not getting 6 is 5 by 6 into probability of getting 6 is 5 by 6. So which is equal to 5 by 36 plus 5 by 36, that is 10 out of 36, and P at x is equal to 2, which implies probability of getting both 6, that is probability of getting the first die 6 and probability of getting second die is also 6, which is nothing but 1 out of 6 into 1 out of 6, that is 1 by 36. So the probability distribution table can be taken as x value and probability at x. For 0 it is 25 by 36, for 1 it is 10 by 36, and for 2 it is 1 by 36. So this is the probability distribution table of random variable x, where x is representing number of sixes in two tosses of a die.